Good day, my name is Estefanía Orbegozo Guzmán and I will present the paper related to the investigation of adhesive and cohesive properties of asphalt, mastic and mortar in porous asphalt mixtures. Things to highlight from this paper in order to have a little more clarity at the time of deepening is that the adhesive and cohesive properties of asphalt, mastic and mortar are investigated, the influence of the properties, and finally discuss the failure mechanisms of the porous asphalt mixture. Porous asphalt mixtures consist of a large amount of coarse aggregates and high air voids. The features are due to the high content of air voids. In this picture, the internal structure and composition of the porous asphalt mix can be observed, and the air voids can be seen. In Figure A, two aggregates are joined by a very thin binder. In Figure B and C, the binder thickness between the aggregates are significantly greater. Porous asphalt mixtures are the results of binding between these three materials. Therefore, it is important to investigate the properties of these three materials. The binder bond strength BBS test is a type of follow-up test, was developed to obtain mechanical parameters and is extensively used to evaluate the adhesion and cohesion of asphalt. The objective and scope of the paper is to investigate the adhesive and cohesive properties of asphalt, mortar and mastic in a corresponding mix. A typical porous asphalt mix with a nominal maximum aggregate size NMAS of 13 period 2 mm PA13 was investigated for the paper. Three types of asphalt are used in PA13, including original asphalt, styrene butadiene styrene (HBS), and high viscosity modified asphalt (HVA) are investigated for the paper. To determine the base to mastic asphalt ratio FB is calculated by conceptualizing that FB of mastic is equal to FB of PA13. The test methods are the BBS test, binder bond strength. This is subdivided into the removal hill, which improves the occurrence of BBS test and the test procedure. To determine the type of failure, as evidenced in the picture, the white area is the aggregate surface and the black area is asphalt. Therefore, the surface area of the substrate covered by asphalt and the surface area of the substrate without asphalt can be calculated. If the surface area ratio is less than 50%, the type of failure is determined as adhesive failure. Otherwise, the failure type is determined as cohesive failure. Since the nominal maximum aggregate size of mortar and mastic is different from that of asphalt, the modified BBS must be done. There is another test which is called indirect tensile test, IDT. In this is important the indirect tensile strength, ITDS, and the Cantabro loss test can be calculated with this equation. In results, it was evidenced that the tensile strength and failure type of different asphalt under different temperatures, adhesive failure in the adhesive original asphalt and HBS modified asphalt at 20 degrees Celsius, while the high viscosity modified asphalt at 20 degrees Celsius failed on the surface of the extraction section at 20 and 30 degrees Celsius. And with respect to the adhesion and cohesion of mastics and mortars, as shown in Picture A, the HBS modified asphalt of mastic increased with increasing temperature. From Picture A to C, in comparison with asphalt and mastic, the cohesive strength of mortar is the lowest when the same asphalt is used. It can be concluded that the cohesive strength of asphalt, mastic and mortar increases with increasing dynamic viscosity of asphalt. The failure type of asphalt changes from adhesive failure to cohesive failure, while the failure types of mastic and mortar change viscosity of asphalt. The failure type of asphalt changes from adhesive failure to cohesive failure, while the failure types of mastic and mortar change from cohesive failure to adhesive failure with increasing temperature. The failure type of mastic and mortar changes from cohesive failure to adhesive failure with increasing temperature. The failure type of mastic and mortar changes from cohesive failure to adhesive failure, with increasing moisture damage. Thank you so much.